here are problems 3a and 3b. We want to find the following derivatives, meaning you have to use the fundamental theorem of calculus. So the derivative of the integral, so f prime of x is the derivative of this integral, which you could totally do as is, remembering that if the variable is in the bottom, you get a negative. Or if you want, you can take the additional step of saying it's going to be the derivative of negative integral from 1 to x of t cubed plus t dt. Either way, you're going to end up getting, well, I'm going to get negative, the derivative of the integral of a function. You just plug in the x and you get x cubed plus x, which is the same thing you would get here, right? You would get negative and then you plug in the x and you get x cubed plus x. And there's no plus c, right? It's a derivative of an integral, there's no plus c. So you get that, which is then, I would probably distribute the minus sign, you get negative x cubed minus x. That's your answer. For 3b, it's a little more complicated because there's a chain rule involved. So we're taking the derivative of g of x equal to the integral from 5 to x cubed of cosine of t over t squared plus 1 dt. So g prime of x is the derivative with respect to x. You don't have to write this part, I'm just writing it because you might see it written this way. So the derivative of the integral from 5 to x cubed of cosine of t over t squared plus 1 dt. And for this one, we're just plugging in x cubed wherever we see a t. So we're going to get cosine of x cubed over x cubed squared plus 1. But then we have to multiply by the derivative of x cubed. And I would probably simplify this just a tiny bit. I'd probably write this as 3x squared times cosine of x cubed divided by x cubed squared is x to the 6th plus 1. You might ask in the previous one why we didn't have to multiply by the derivative. Well, we actually technically did, right? But the derivative of x is just 1. So technically we did multiply this by 1. It's just not written, right? That's problem 3.